Okay, so we're going to be talking about derivatives and rates of change. So if you remember derivatives, they give you the slope of the tangent line at a particular point, yes? And the way that we found that was by taking the limit of the secant line. Okay, so there's some interesting ways that we can look at this and think about it. Okay, that's not the window that I wanted. This is the window that I want. Okay, so let's draw this. Okay, so this is easiest to draw with a picture. Okay, so here's our axis. So let's say that you have your function. Here's your f of x. Okay, let's choose a point on it right here. Right here is going to be x equals a. So the y value of that is going to be f of a. Okay, so you have your x value is a, and then your y value is f of a. And our second point over here is going to be a plus h. Okay, so what is the delta x between those 2 points? What is the change in the x values? For these 2 points, the blue and the green point, what is the delta x? Or h, exactly, perfect. The change, okay, what the hell? It's not letting me write. There we go. The change in the x value is h. Now, the y value for this second green point is f of a plus h. So you can see that the y values, there's a change in the y value. That's delta y. And the change in the y value is f of a plus h minus f of a. Does everyone recognize where that delta y, where we've seen this before, the f of a plus h minus f of a? Like, where have you seen this before? Where have we seen that? No, it cannot. But where have you seen f of a plus h minus f of a? The delta y. Yeah, the definition of what? Yes, well, not limits of something else starts with a d. The derivative, right? Remember how we have the limit as delta x goes to 0 of delta y over delta x? That's your derivative at that point a. The limit as h goes to 0 of f of a plus h minus f of a all over h, right? This one is your delta y. This one is your delta x. Okay, so they have names. Delta x is the change in the x value. Delta y is the change in the y value. Okay, so the top part change in y, bottom part change in x. And what you realize is that you can actually use derivatives to sort of like figure some stuff out. So the derivative, this stuff, that is the change at x equals a. The instantaneous rate of change at one point. Okay, but if you look at this, just the part in red, the difference quotient, that's the average change between a and a plus h. So remember we started off with the secant line, and then we had our 2 points, the one at a and the one at a plus h, and then we took the limit to make it 1 point, and that's how we got the change at the instantaneous rate of change. Okay, so derivatives, the whole point of looking at this is to remind you that derivatives are all about rates of change. And we're gonna use this formula, this setup here, to like solve some stuff basically. So I want to point out that the change in x is the change between this point to this point, this distance right here. And the change in y is the change between those 2 points right there. And sometimes, so let's write this down. Sometimes you know the value f of a, but you don't know the value f of a plus h. Okay, and there's a way. So what we're going to do is we will use derivatives to estimate the change in y value, i.e. figure out f of a plus h. So what we're doing here is, like, you know what this value is at this blue point right here. This one you know. And you want to figure out the value over here. Okay? How can we do that? So the way that we're going to do that is the fact that the derivative at a is equal to that limit of all that stuff, right? So it's equal to the limit, which means that it's approximately equal to this. All the stuff inside the limit without the limit. Okay, so the derivative is going to be pretty close to being f of a plus h minus f of a all over h. And then what we're going to do is we're going to multiply both sides by h. So you get f prime a times h is approximately equal to f of a plus h minus f of a. Okay, now remember, you know this value, and you want to figure out what this one is. So if you add f of a to both sides, you now know what f of a plus h is approximately equal to. So you want to know this value, and you have an approximate formula for it. F of a plus h is going to be approximately equal to f of a plus the derivative at a times h. And there's a reason for why this works. I'm going to draw the little picture. You know this value right here at x equals a. Now let's draw the tangent line. Okay, why is it not letting me draw a tangent line? There we go. Okay, here's your tangent line at A. So let's say you want to know this point right here. Your x equals a plus h. So this is the one you want, and this is the one you know. This formula right here, this is actually the value you get by finding this point on the tangent line. So this is this. So right here, this point in blue, that is f of a plus h, which you want. And instead what you're finding is this point on the tangent line. And if you look at those two values, they're pretty close to each other, right? Okay, so this is called a tangent line approximation. Okay, you're using the derivative because the derivative is the slope of the tangent line. You're basically using that to estimate the value that you want. Okay, and this difference between them, this little height right here, that's called the error of your estimate. So let me pause, see if there are questions. I'll give you an example of like how you can use this. Or should I pause longer to let you write, or how are we doing? Let me check in. Yeah, we'll go down, I guess. If you need to, ask me to go back up. Let's do an example. Okay, so for this example, what should our function be? Like, what should the inputs and the outputs be? Like, let's come up with something funny. Let's say x will be the number of hours, and what is y going to track? Like the number of something. So x will be the number of hours, and then y will be the total number of something consumed. Total number of what consumed? Cool, total number of coffees consumed or drank. Okay, so if I say f of 3 equals 2, what does that translate into words? So like if f of 3 equals 2, that means that after 3 hours, yeah, I have drank 2 coffees. Awesome, cool. So does that make sense to everyone, like what it means? Like f of 3 equals 2 means that after 3 hours, I have drank 2 coffees. Now, let's say that f prime of 3 equals 5. Okay, the derivative is a rate of change. So what that means is that after 3 hours, my rate of coffee drinking is 5 coffees per hour. Does that make sense? Like at that time, at the 3 hour mark, it looks like I'm gonna keep drinking 5 coffees per hour. Because remember, the derivative is a rate of change. Right? The derivative is the change in y over change in x. What is your units for y? Number of coffees. And what is your unit for x? Hours. So does that make sense? That's how I know that f prime of 3 equals 5 means 5 coffees per hour. Because the 5 is 5 over 1, technically. Okay. So, now the question is, estimate the number of coffees drank after 3.2 hours. So at time 3 hours, I've drank 2 coffees. Now we're wondering, well, given what you know, how many coffees will have been consumed? Okay, so this 3.2, that is your A plus H. The 3 is your A. Okay, so A equals 3. A plus H equals 3.2. So my difference, my elapsed amount of time, H, is 0.2. Does that make sense how I found those two? You give the information that gives you the derivative, that's going to tell you what A is. My A is 3. The new time is 3.2 hours. H is the elapsed time. between the two of them. Okay. Now, why am I identifying all this? Because we have the formula. F of A plus H is approximately equal to F of A plus F prime at A times H. So you plug in the numbers. Well, A plus H was 3.2. F of A is F of 3. F prime of A is F prime of 3, and our H is 0.2. Okay, then you can start plugging in the numbers. F of 3 was 5. F of 3 was 2. F of 3 was 2. F prime of 3 was 5. My H is 0.2. 5 times 0.2 is 1. So at time 3.2 hours, how many coffees do I think I will have consumed? 3. Okay, I tried to do this with an example that would make like physical sense, right? Like with like the total number of coffees that you have drank. Okay, but like they might be all sorts of units or not even have it units. The whole point is that you're using this to estimate the value of something. Your goal was to estimate what f of 3.2 was. We estimated it as 3. In this case, that meant 3 coffees drank. How did we do this? Because we knew how many coffees you had drank at 3, and you had the rate of change at 3. It has to be, or you have to have some way to figure it out. The trickier problems, usually that involves you having to use some other information to figure out what the rate of change is.